Indirect variation. It's sometimes called inverse variation, but that's neither here nor there. Direct variation kind of makes sense usually. Direct variation basically says, in direct variation it's kind of this, as one thing goes up, so does the other. As one thing goes up, so does the other. Now let's do a hypothetical situation here. Do any of you have jobs in the summertime? Like working for somebody besides your parents? Jacob, who do you work for?
My neighbor.
Your neighbor. Jacob, how much do you make an hour?
$5.
$5 an hour. Okay, so here is the deal. Let's look at that. Here's Jacob's money-making chart here. Jake's cash. Okay, and we're going to let X be the number of hours he works, and Y is how much money he makes. X is hours, Y is cash. Did you say you make how much?
$5.
It's pretty good for somebody in 8th grade. Okay, you make $5. Alright, Jacob, let's start with the thing. It's been a bad week. Jacob's had baseball every day of the week. He didn't get any time in there. How much is Jacob going to make? Nada colada. He works 1 hour, he's going to make $5. He works 2 hours, and let's skip a few. He works 5 hours, he's going to make 25. Jacob, what's the most you've ever worked?
Like
for this lady?
3 hours.
You are rolling in the serious cash, man. In one day or like all week long?
No, 1 day.
1 day. Okay. Well, let's say Jacob gets, he has to mow the lawn and rake the leaves and take out the garbage and wash the dog and feed the pig or whatever. He makes $40 there. This is an example of direct variation for a couple of reasons. Okay. The first thing is this: if we were to write a formula for this, y would equal what? Y would equal, here's x. What do I have to do to what do I do to x? When I put x in here, what did I do to x to get y? My little input to output source thing here. What did I do, Calvin? I multiplied by 5. Okay. A couple of things here. This is directly proportional because the more Jacob works, the more money he makes. See, now if it was inversely proportional, or indirectly, I guess we could say, it would make a lot of sense because the more Jacob would work, the less he would make, and that's not a good thing, is it, Jacob? Because I don't think Jacob would particularly like to, he'd work 8 hours and make $5, and yet work 1 hour and make $50. It wouldn't make any sense. Okay. So this number 5 that we multiply by, okay, has a wonderful name. It's called the Constant of Proportionality. It's the Constant of Proportionality. And anything that's in direct variation has to have one of those. Okay, it has to have a constant of proportionality. Christine, will you close that door? And in this case, it was a 5. It could be, let's say next year Jacob gets a raise, and he's making $6 an hour, we change to is that what you work for? Pretty soon we'll be out there. Minimum wage is going to be at $20 an hour pretty soon. That's probably annual. That's a good one there. Now, so in order for things to be direct variation, write this down here, to be direct variation, number one, it has to have a constant of proportionality. Must have a constant of proportionality. And number two, ladies and gentlemen, and people of all ages, okay, it must, when x is 0, y has to be 0. which means this. I think we talked about being proportional before. Do we have to talk about what it takes to be proportional? Is that you guys, or is that some other class? In other words, if you are graphing Jake's money he makes on a graph, and you're plotting these XY points as ordered pairs, okay, when X is 0, Y has to be 0. It has to go through the origin. 1 is 5, so 1 is here, 1, 2, 3, 4, 5. We get that there. 2 is 10, it would be up here. When you draw that line, it has to go through. Jacob, if you worked negative hours, would you pay the lady? Okay. You have to according to our graph. Good thing is you can't work negative hours. Although sometimes in math, many of you seem like they work negative hours there. Take a look at page 464 of your book. I want you to see some of this stuff here. Maybe I'll draw the table up here. 1, 2, 3, 4. The question they ask in example 1 is which of these is direct variation? Is it direct variation? That's the question. Look at, you see where I'm at the example number 1?
Yeah.
Letter A says, a taxi company charges $3 to start the ride plus $2 per mile. Okay, and that's usually what happens when you ride a taxi. Why would a taxi company charge you $3 no matter what?
So it's the money.
Calvin?
Because we go up 2 blocks.
Yeah. If they charge you $5 a mile, but you tell them I only want to go 1/8 of a mile, do you think the taxi guy is going to make any money if you take 5 divided by 8 and get whatever it is, 70-some cents to take you 2 blocks? Okay, so in order that the cab company make sure they get some money, they charge a flat fee, which that $3 is there. So it looks like this. We could draw our table here with this. X and Y. How much would we say it was? You have to pay $3 no matter what, right? $3 no matter what. And then it's what? $2 a mile? Is that what it was? Help me out here. Nobody's reading with me here?
Yeah, it is. Yeah.
So here's the deal. If you didn't go anywhere, you still have to pay the $3 no matter what. Okay? If you went 1 mile, how much would it cost you? Right. $3 no matter what plus $2 a mile. So it's 5. If you went 2 miles, it cost you $4 for this plus the $3, it cost you $7. The question is this direct variation based on the 2 things that have to happen, which are, number 1, when this is 0, this has to be 0. So right away, when you see that happening, this would be no. Okay, because of this reason here. You can stop right there because when this is 0, this has to be 0. There can never be a flat fee to be direct variation. Okay, look at the second example. How about the area of a square? Area of a square. How do we find the area of a square? You take the side and square, right? Let's look here. This one I think will make you happy. If you have a side that has a square that has a side of 0, what's its area? Wow. So right now it works so far, right? A square with a side of 1 is area of, here's your square, it's a 1 by 1 square, its area is 1. You have a square that is a 2 by 2 square, what is its area? Yeah, you have a square, its area is a 3 by 3, it is. Now, the question is that direct variation? I'll entertain any notions to that, yes or no. Christian, what do you think? He says with great certainty, no.
is.
Yes, it is?
So, I mean,
Wait, yes, you're certain about your no? Alright, why isn't it, Christian?
because it's 0 at the top.
No, you can have zeros. You can have this zero as long as that's zero. Huh?
Not if there's 2 zeros, it's not.
No, it has to have 2 zeros at the top to be directly proportional.
Oh, then it is.
Oh, then it is. Should we finally change our minds? Lutz, what do you think? Yes or no? Okay, once you see that it's 0, 0, the second question you ask yourself is there a constant of proportionality? Which means this. What do I do with 1 to get to 1? Multiply it by what? 1. In order for this to be directly proportional, everything in the x column would have to be multiplied by 1 to get y.
No.
Okay, so 2 times 1 doesn't give you 4, and 3 times 1 certainly doesn't give you 9. As a matter of fact, if you graphed this, you know what the graph of that looks like? Of course you don't, because you've never graphed it. Okay, 0, 0, 1, 1 looks like this. 2, 4, 1, 2, 3, 4 looks like this, and 3, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's not even a straight line, it's a little curved thing, it just keeps shooting up like this. Okay, so this is not directly proportional, even though it goes through the origin, it doesn't have its constant of proportionality. And the last one, perimeter of a square equals 4 times s. If you think about a square, okay, if a square has a side of 0, what's its area, or what's its perimeter? 0. If it has a perimeter of 1, 4, a perimeter of 2, and a perimeter of 3, 12. So you ask yourself the 2 questions, which are, does it go through the origin? Is it 0, 0?
Yes.
And do you multiply by the same number every time you go from x to y? So 2 times 4, your constant of proportionality is that 4. And the answer to this is absolutely yes, it is direct variation. Isn't that somewhat exciting? You won't go there. Indirect variation gets a little more complicated. That's certainly not something like that. Look at page 467. Actually, it is next year. Inverse variation. Yeah. What would be an example of inverse variation? Anybody know? Great.
If it's not proportional.
Yeah, but I mean a real life example.